All right, I'm going to the whiteboard, number 4. Let's take a look at it, the fourth root of 18. Let me push this up. And again, what we're trying to get a feel for it. So the fourth root of 18. And, looking at it, I hope you realize the fourth root of 18, we're looking for perfect fourth powers. So I'm gonna bound it using integers, and that's what we do here. So fourth root, well, the fourth root of 16, that's below it. And what's above it? The fourth root of, well, let's see, that's 2. So now we're doing 3, and that would be 81. So this is equal to 3, and this is equal to 2. I hope you know by looking at it that this is certainly closer to 16 than it is 81. So the fourth root of 18, right, is going to be close to 2 it's going to be close to 2 point something. What I mean by that, I'm going to say, something close to this over here. It's not going to be anywhere near 3, right? But I still want to go through it with you, all right? So I'll write this over here. The fourth root of 18, I could write it down as the fourth root of 16 plus 2, and there's a point to it. Or I could write it down as a fourth root, 81 minus, let's take a look at this. So 81 minus 18, right, that's going to be what, 63, isn't it? All right, so I have to put that down, 81 minus 63, okay? They're both going to be equal to 18, by the way. 16 plus 2 is 18. 81 minus 63 is going to be 18 as well. So what do I do over here? It's really the same old story. We've been doing this for a while now. I'm going to factor out a 16, and you would get 1 plus 2 sixteenths. What do you get over here? This is the fourth root, 81 times 1 minus 63 over 81. And by the way, I'm looking for the smallest fraction. It's going to converge the fastest. This one, all right? So I'm going to use this guy over here. So let's write this down. The fourth root of 18, well, the fourth root of 16 is 2, and then I'm going to be left with this over here, which is 2 plus, well, 2 sixteenths is just 1/8, and I'm raising it to the 1/4 power. And what am I going to do now? I'm going to do my expansion, the expansion that we've come to know over time by practice. So let's write this down, 2 and 1, and that's going to be 1/4. I'm sorry, I said 1/18, it's 1/8. My mistake. Let me erase that. I just noticed that. 2 sixteenths is 1/8. Sorry about that. And 1/8 is definitely smaller than 63 over 81. So it's going to be 1/4, 1/8. The first two terms are pretty easy. It's not a bad approximation if you want to just leave it there. But again, we're trying to expand this guy here. And the expansion goes on forever. So 3/32, 1/8 squared, plus, and these things have been done already. That's why I'm writing them down. I've already done them. And they're in your notes, right? The expansions, we did those expansions, and they're good to go. And then minus 77 over 2,048. Wow, that's going to be a crazy number to compute with. And again, you probably should admire that how difficult it was for people during Wells's time to do these computation. But really what I'm looking for you to do is, I'm not really interested in the computation, to be honest with you, but it's remarkable how good it is, all right? So if you do this on your calculator, you can get an approximate number for it. And again, I'm going to claim on your calculator, like 2.0. I'm going to say, there's numbers there, right? 2.0. I'm going to say just to two places, 2.06. And so, how many places you want to get? Your calculator, and I don't have a calculator handy, can write out, like 15 places of accuracy. What I'd like you to do, though, is experiment with this guy over here. Start doing the computations. See how quickly it goes to the number that your calculator is reporting back to you. It's impeccably good. And why is that? This fraction's quite small, and you're expecting to converge much quicker, all right? And that's about it. It's computation, all right? How do you do computation nowadays? Digital computer. That means your four-function calculator, your cell phone, or possibly if you're using a computer and Sage, all right? Thank you.